So in the last session, we imported the Anchor SPL, which is a Solana program library, and we took the token library from there, and we got the burn, mint to set authority and transfer functions. And here we have just defined functions, which are proxy, transfer, mint, burn, and set authority. And from this, we have directly used the functions that are present within this token library. And we have taken the accounts. There's some info that is coming from here, and then the amount. Okay. So these are the things we have already done. We've created an authority type, okay, which is here. Ignore. Mint the token authority, or they have the authority to freeze the account. They are the account owners or close account. Okay. Then we have created the proxy transfer account, which can be passed into the context, which has authority, who's the signer, then from and to for the transfer part, and which token program, that means which SPL token are we actually going to be transferring. Then mint, again, there is mint account, then there is to which account we should mint and the token program. Authority, again we have burn, okay, to, I don't know what is to here, maybe we have to check. There is again mint, I think maybe it mints to a zero address or something, I have to check this. And then there is a set authority, where who is the current authority, whether it is for an account or whether it is the minting account, and the token program. Okay. Now for the CPI part, cross program invocation, they have given us, okay, so I think this part then we had done, serialize and deserialize. This part also we have done. We have created the enumerator, defining our first account struct. This also we have done, defining all the other accounts. This also we have done, say hi to cross program invocation. Okay, so before we go to that, there is this cross program invocation by Anchor book, by Anchor. Let's see. Anchor book also has a good cross program invocation. Please here. So okay, maybe we should do, if you all have already done this, we can skip this, or we can just continue with, just do like a quick, what is this CPI kind of thing. Let's see. Shweta, what do you think we should do this, or should we skip it and directly do the contract part?
I guess if this is required for understanding, then we should do it.
Yeah, okay, let's do it very quickly then. So cross-program invocation is basically cross-contract calls. So it is useful for programs to interact with each other in Solana. And okay, let's see the example of a puppet and puppet master. Okay, probably both are the same. These two links. Admittedly, it's not very realistic, but it allows us to show you the many nuances of CPIs. The milestone project of the intermediate section covers a more realistic program. Okay. Okay, let's just go through the program, because I think we'll be doing something similar in our program. Okay, so we have a module puppet. It uses super. Okay, this is I think standard. Then we have a function initialize, and then we have a function set data. Initialize is just having a context initialize, and set data has a context set data, where in this particular context there is something called puppet, which this is using and assigning this, and then it says puppet.data is equal to data that is being passed. Okay,
all good.
then initialize has puppet, then user, then system program. Okay, so this is an account associated with data. Then set data has again this puppet account, which is associated with data, and data is nothing but,
you can sit here बच्चा, मैंने तो मेरा एयरपोर्ट ऑन है, आजा तू.
let me mute करती. There's nothing special happening here. It's a pretty simple program. The interesting part is how it interacts with the next program we're going to create. Okay, so here it is just assigning some data. Now inside the workspace, okay, go run this one inside the workspace and follow. Okay, copy the following code. So we have here Puppet, which is this particular module, and we are taking from this CPI accounts set data. So this is the set data account, which we are taking from this Puppet module and using it here as a crate. Then we are taking Puppet program and the name of the program itself, that is Puppet. And then we use the data aspect from Puppet as well. So I think self is like how they're using it over here, similar to that. Okay. Here we say, okay, we have created a new module, Puppet Master. Here this has a function, pull strings. This has similar context, and then there's a data. Now here what they are doing is the CPI program is coming from this context, accounts, Puppet program to account info. That means there must be a Puppet program defined, you can see here, which is actually a program object, not account. So this program is related to this Puppet, which it is taking from the crate, this Puppet object, and it is trying to find the to account info here. So the Puppet object, whatever is the account where the Puppet program is deployed, I'm assuming it will bring out that particular program's info here, CPI program. Then the CPI accounts, it uses set data. Oh, so it is taking the set data account where the data is actually stored. And within this, we are trying to extract the Puppet object. So this set data has this Puppet object. This is what it is trying to extract here from the to account info. And then it is creating a CPI context, which is a new context, wherein they take the CPI program and the accounts. And then using this new context, they are calling the set data of this function. Oh. So they're using Puppet CPI, then they're calling this set data with this new context that they have set here. This is the context that is being sent and the data that they want to set, the new one. And this will go here and update this particular set, this puppet.data is equal to data. So we have to create a program, we have to get the program from the accounts context, from this context. We have to get the accounts in which the program is stored. Then we have to create a context which will contain the program and the account, and use this context to make a cross program invocation. Okay, so there are 3 steps. This is okay, this is straightforward. We have Puppet and Puppet program. Also add the line, sorry. Also add the line Puppet master is equal to in the programs. Okay. Finally, import the Puppet program into the Puppet master program by adding the following line to the dependency section of the cargo.toml. Okay. So something like this. We have to add features as CPI and path as, okay, the path where this Puppet program is stored. The features is equal to CPI is used, so we can not only use Puppet's types, but also its instruction builders and CPI functions. Without these, we would have to use low-level Solana syscalls. Fortunately, Anchor provides abstractions on top of these. By enabling the CPI feature, the Puppet master program gets access to the Puppet CPI module. That is this module. Okay. An Anchor generates this module automatically, and it contains tailor-made instruction builders and CPI helpers for this program. In the case of the Puppet program, the Puppet master uses the set data instruction builder struct. Oh, this is the instruction builder. They're saying this one. Instruction builder struct provided by the Puppet CPI accounts module to submit the accounts the set data instruction of the Puppet program expects. Then the Puppet master creates a new CPI context and passes it to the set data CPI function. This function has the exact same function as the set data function in the Puppet program, with the exception that it expects a CPI context instead of a context. I see. Okay. So this set data, when called from here, will expect a CPI context instead of a plain context. Setting up a CPI can distract from the business logic of the program, so it's recommended to move this CPI setup into the implementation block of the instruction. The Puppet master program then looks like this. So, okay, so we create the account here and we implement this struct. So the pull string struct, we implement it here. And then we are creating the CPI context here and returning it. And from here, this is taking this CPI context from this implementation and using it to call the other main Puppet program. Okay. This seems like slightly complex, but maybe if we keep practicing, we will get it. Okay, so let's try to do our program now. Okay, we did briefly talk about cross-program invocations. CPIs are used to invoke instructions on another program. To do so on our Anchor is pretty straightforward since it does a lot of stuff for us under the hood. Sorry. All we need to do is create a CPI context object with the target instructions account and program. Correct. So we need two things, account and program. To perform CPI, just use the CPI module. Accounts used for CPI are not specifically denoted as such with the CPI account label since version 0.15. Accounts used for CPI are not fundamentally different from program or signer accounts, except for their role and ownership in specific context in which they are used. So now with the above points in mind, let's create implementation blocks which we will use to create the CPI context. We will later use the CPI context to invoke instructions from other programs. Okay. So for every action, now we have to create these implementations. Okay. Store it. Proxy transfer. Implementation. We have to learn about this like apostrophe A kind of things. Okay, there is a from. Okay, info for CPI context. Okay, and then okay, then we use the same proxy burn. I don't know what this from signifies. Meant to. Okay. So we do proxy meant to here. We say meant to not transfer it. Okay. Then take this, do proxy burn, and then just proxy set authority. Okay, and just set authority. After writing all these, your code screen should look something like this. Yes, it does. Oh, okay, I have done the implementation for each of them below the struct itself. Okay. Our first CPI. In the last quest, we created all the implementation blocks for creating the CPI context that we will now use to call the functions from the other program. Oh. Remember the strange into keyword we used earlier while writing our program functions without any explanation? What are the into keywords? Oh, into? No, info, right? Well, let me then introduce you to the wonders of Rust language. Rust language provides something called the from and I think info, I don't know, from and into traits info, right? Okay, I'm assuming it's info, which is essentially a cool way to convert type A into type B. Okay, this definitely warranties some reading. From and into. Oh, into, but in the quest there is no into. Okay, let's just read this. The from and into traits are inherently linked, and this is actually part of its implementation. If you are able to convert type A from type B, then it should be easy to believe that we should be able to convert type B to type A. Okay. The from trait allows for a type to define how to create itself from another type. There are numerous implementations of this trait within the standard library. Okay, for example, we can easily convert a str into a string. Okay, so my str is just an str type, and here when we use a from trait, it can be converted into a string. Okay, we can do similar for defining a conversion of our own type. So we say number type, okay, and we say 30 is converted to a number, and a number type is signified as value. Okay, so I32 basically, that's what they say. Now into trait is simply the reciprocal of the from trait. That is, if you have implemented the from trait for your type, into will call it when necessary. Using the into trait typically require specification of the type to convert into, as the compiler is unable to determine this most of the time. However, this is a small trade-off considering the functionality for free. Okay, so we see here number int dot into. Oh, so it's essentially the same syntax. Syntax is just different, but what it's doing is the same, right? I think so. Uh, if you have implemented the from trait for your type, that is the number type, the from trait, if I have implemented, then I can use into to convert any variable into that particular type. Okay, fine. Okay, essentially they're doing the same thing. So into traits, okay, convert. Okay, cool. Since we know from the last quest, oh wait, where is the into? But oh. Since we know from the last quest that we require a CPI context and a list of accounts to perform the CPI, and we also know that the functions that we had written are performing CPI. So logically, we come to the conclusion that now we must write from implementations for those into that we used so that they can be converted into the required format, which is CPI context and CPI accounts. So let's see the first implementation of our from. Oh, this is the from. Okay. So from. Okay, so we are using, we are defining this proxy mint. We are defining the from for this proxy mint. Something like this. For CPI context. Okay. We write down the code below. Oh God, this is long. I will copy and then let me look at it. Proxy transfer. Okay, so function is from. Okay, I think similar to this from, and then the accounts are proxy transfer, and it will return a CPI context. Okay, so CPI accounts, it takes the transfer just like that set data. The from is the from account. The to is cloning the to account, and authority is cloning the authority variable. So we get the accounts. Then we take the program from the accounts.token program, and we now have the program and the account, and we can create a new CPI context, which this function will return. All right, now let's try to write this one for proxy mint. So I say proxy mint, okay, PI context mint to here, okay. So mint has what? Mint has authority, which I have cloned here, okay. It has a mint, which is accounts.mint clone. It has a to, and the token program we will take here, accounts.token program, and then we will create a new context. Okay, we'll check this later. Then we'll try writing the proxy burn as well. So the proxy burn will have the burn account context within it. Here it will be burn. So what are the things it has? It has authority, it has to, and it has mint. And in the token program, we take it for the CPI, and here we create the new context. Okay. Then we will try to write the set authority. So here it will be proxy set authority and returning the set authority context. Okay. Now set authority. Set authority has a current authority under the account. So this current authority will be accounts dot current authority dot clone. Then it has an account or mint. So that's the one here. So I'll just copy this. That is authority is nothing but current authority. So that is done. And then it takes the token program and creates a new context from the program and the accounts. Okay, now let me just go through here. Code should look something like this. One second, let's see how it looks. From to, yeah, implementing all the other from blocks. Okay, I'll quickly do a check now. Proxy mint 2. Proxy mint 2 here. Okay. CPI accounts mint 2 authority. Yes. And then, okay, amazing. Then proxy burn, we have same mint 2 authority. Then, okay, proxy set authority has account or mint. Okay, current authority, only 2 things. Okay, this one and this one, and then CPI program, accounts token program, clone. Okay, great. Awesome. Now all the proxy functions that we wrote earlier are ready to work perfectly except for one fine detail. Since the implementations are more or less identical, we can move on to the next quest where we figure out the one final piece of the puzzle. Okay. Remember the quest where we talked about enums and account serialize and deserialize? That is this one. You might be wondering, all is good with enums being used to refer to different states with convenient names, but where exactly did we define the states? Oh, right. We did not define, and in this quest, we'll be doing exactly the same. We'll be assigning meaning to the names within enums using the concept of implementation for blocks. Let's quickly do this. Implementation for blocks. The implementation keyword is primarily used to define implementation on types. Inherent implementations are standalone, while trait implementations are used to implement traits for types or other traits. Functions and cons can both be defined in an implementation. A function defined in an implementation block can be standalone, meaning it would be called like, okay, function defined in an implementation block can be standalone, correct, like this, function boo or whatever, answer. If the function takes self, blah, 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 as this was, it can also be used called, okay, using method call syntax, a familiar feature, yeah, correct, foo.path. Now here, so we have a struct example and we are creating an implementation for it. Okay, so it has some functions here, boo, answer, get number and all that. Then we have a trait called thingy and it has a function. This implementation is implementing this trait for this particular other implementation. So it is calling this function and it is actually, the function code is here. Okay, I think we should do a little more studies on this. The other use of implementation keyword is an implementation trait syntax, which can be seen as a shorthand for a concrete type that implements this trait. Its primary use is working with closures, which have type definitions generated at compile time. Okay, what are these closures? Need to see. Function thing returning closure is actually returning an implementation of a function I32, which in turn returns a bool. So println, here's a closure for you. Okay. We should mark on our study this one, that we need to study implement traits. Okay. Then, so we'll be assigning meaning to the names within enums using the concept of implementation flow box. Write the below piece of code to implement the enum that we defined before defining the different account structs. Below skeleton would be later on filled to match the enum with corresponding. Okay. Remember the match syntax a little bit. Define the implementation here only, so it is clear. So there is the from that we are using for SPL token instruction authority type. Okay. So this returns the authority type. Okay. This skeleton of the implementation block is almost the same as previous blocks, apart from the difference of from versus for, right? I don't see the difference. Okay. That's what? No, last time also it was for only. From for. Okay. Gotta ignore this. Now the implementation going inside the block would be different since we are assigning values to a constant and not converting anything into anything. So we do match and then better to type it down. Authority T5. Okay, and now we will say authority if the authority type is mint token, then you choose the SPL token, then return this. If the authority type is freeze account, then account. Okay. The authority type is account owner. Then from the SPL token library, return if it is of type close account, then okay. So now we have created this match. Match keyword is used in Rust, can be thought of, yeah, this one we am familiar, can be used like a C switch. Okay. The first matching arm is evaluating all possible values must be covered. Okay, syntax. Okay, checking our code. Anchor bit. Okay, so then okay. See, the code compiles. That's good news. Our anchor program code is working fine, and we can move ahead. You're facing some errors. Re-verify that you properly followed. Okay, let's see. Oh. Building. Okay, so there is result. Okay, let's go. Use anchor. Okay, use anchor SPL. Help add. Okay. Help add this here. Unexpected token. Fan. No method info found. Oh, lib.rs11. Is this into what? Into what? Okay, let's see. Standard result found implicitly returns as its body has no tail. You consider removing this semicolon. Oh, okay. So, okay, into then result into, you said authority type. Okay, okay. Consider sample. Okay, let's try this again. Okay. No method name 25. 5. Oh. Okay. Okay. Oh, good. Stuck field authority is unsafe but is not documented. So error. Error. Struct field authority is unsafe but is not documented. Please add ## check doc comment explaining why no check through types are necessary. Where should I do it? Line number 53. I just added this. Cool. Safety checks. Let's see. Chapter 3. There's no safety checks in chapter 3. Account struct. Where can I see this? Okay, maybe we'll map this. Okay, once this is done, importing the necessary code required for testing our content. Okay. We have 7 more minutes, so let's just do this off quickly. Tests. TS and Oh, wait. So they are writing tests in JS, but actually, isme they are writing in TS. So I don't know if it will work. शोभित ये टाइपस्क्रिप्ट और जेएस में क्या डिफरेंस है?
मेनली टाइपस्क्रिप्ट में आपका मतलब स्टैटिक भी टाइप होता है, तो जो भी है सब टाइप पहले से बताना पड़ता है वेरिएबल्स का, बाकी मेन कोई चेंज नहीं है।
तो ये चीज चल जाएगी ना? अभी अगर मैं इसको हटा दूं और एग्जिस्टिंग चीज को रहने दूं, ये तो विल दिस बी फाइन? ये तो यूज कर नहीं रहा ये माई मनी डैप, बट यहाँ पे प्रोग्राम एंकर डॉट वर्क स्पेस माई मनी डैप को इम्पोर्ट करने की कोशिश कर रहा है, तो ये डायरेक्टली आई थिंक ले लेगा। आई थिंक सो।
हाँ, डायरेक्टली ले लेंगे। हाँ,
वर्क स्पेस से ले लेगा, राइट? इसको अलग से इम्पोर्ट करने की जरूरत शायद नहीं पड़ेगी। ओके, तो ये प्रोग्राम पता नहीं कहाँ से लेगा, क्योंकि यहाँ से ये वर्क स्पेस से ही ले रहा है प्रोग्राम भी। अच्छा, ये ओके, लेट्स सी। ये लोग असर्ट भी ले रहे हैं, तो मैं इसको असर्ट कैसे यहाँ पे इंपोर्ट करूँ? रिक्वायर असर्ट बोल रहा है, तो इसको मुझे ऐसे कुछ इंपोर्ट करना पड़ेगा क्या? असर्ट या तो टाइपस्क्रिप्ट में बाय डिफॉल्ट असर्ट विल बी देयर क्या? ट्राई करते हैं। Ideally, while testing this contract, we should have been able to use simply Solana web3.js to interact with our Anchor program. Depending on Serum. What that also means is that we cannot simply import and use Solana Web3 until Project Serum is the same version. So mimic the function, simply copy and paste the following code. Can you do one thing, Shobit? Can you try out just this testing part ek bar on the TypeScript one and then update us key how it is working? I think we have to write the TypeScript test by ourselves. I don't think this, whatever they have given, will work. Because ये सब async function type of things they are using, but will this work in TypeScript? No, right?
नहीं functions तो चल जाना चाहिए.
ये async function types इस तरीके से.
हाँ हाँ वो चलना चाहिए.
Okay, anyways, you will be trying out this repo, na?
हाँ.
Just try it out once and see if you're able to do the TypeScript tests. Then we can just use that and just like वो repo share. You can share the repo. We'll share it with people.
हाँ. Sure.
Cool. Okay, ठीक है. So if you face any errors, just let me know or just let us know in the group only. Okay, awesome. Okay. Do you have any questions?